right, so today we are going to talk more about particle motion in regards to definite integration. And there are three things we always want to keep in mind. And the first thing is if you're taking the definite integral of velocity, all right, you are essentially finding the difference between the two positions of the upper and the lower limit, all right? The second thing is if you're taking the definite integral of velocity, that value equals the net distance the particle travels from A to B. Remember, if the velocity is greater than 0 on this interval, then it also represents the total distance, because the net integral of the absolute value equals the total distance the particle travels on the interval. And this is regardless of whether the velocity is greater than or equal to 0. All right? To be safe, always do the absolute value integral when asked to find the total distance when given velocity. All right? And that's really, really important. Okay? So let's look at this in regards to some problems. The first problem says the velocity of a particle that is moving along the x-axis is given by the function v of t is equal to 3t squared plus 6. And they're asking in part A, if the position of the particle at t equals 4 equals 72, what is the position when t equals 2? Now remember, all right, what's important here is that this is a non-calculator question. All right, so because we're talking about position, all right, we know that if we take the definite integral of velocity, that's going to equal our position. Now, because we have a we can have a definite integral here because they tell us what the position is at t equals 4 and what the position is at 2. So you could write it like this, which means that the definite integral from 2 to 4 of velocity is equal to the position of 4 minus the position at 2. All right? So, if we did that of our velocity equation, we would get t to the third plus 6t plus c from 4 to 2. All right? That's what we're saying, and that's going to equal p of 4 minus p of 2. Okay? So we would plug this in, and we'd get 64 plus 24 plus c minus 8 plus 12 plus c equals p of 4 minus p of 2. All right? So we would get 88 minus 20. All right? So that's 68 is equal, the position at 4 is 72 minus the position at 2. So we would get negative 4 equals negative p of 2. So p of 2 equals 4. All right, so the position at time equals 2 equals 4. All right, for part B, it's asking what is the total distance? All right, and from 0 to 7. All right, so what we can do is we're finding the total distance is equal to the definite integral of the absolute value of velocity. All right, so in this one, what's important is because we have all positive values, all right, within our function, all right, we can just do from 0 to 7 of 3t squared plus 6 dt. So that would equal t to the third plus 6t plus c from 7 to 0. All right, so we get 3, let me take that back, 7 to the third plus 42 plus c minus essentially 0 plus c, because we know every time we plug in 0, it's 0. And we get 385 as our final answer. All right, so now I would like you to do 1 on your own. Okay, I'd like you to do number 2. The velocity of a particle that is moving along the x-axis is given by the function v of t is equal to 0.5 e to the t times the quantity t minus 2 to the third. Now this is a much more complicated velocity equation, and we can't use our basic definite integration that we know with polynomials. But what's key about this is that this is a calculator active question. And because it's a calculator active question, you want to use your calculator when finding the definite integral. So just as a reminder on your TI-84s, okay, if you hit the button math, all right, and then you hit the number 9, okay, which says function integral, okay, you will get a definite integral on your calculator. All right, and then you just need to fill in the upper and the lower limits, the function, and next to the d, make sure you put x because that's what you're using in your equation. All right, or if you choose to put the function and use this one as t instead of x, then put dt. Okay, it just needs to be the same variable. So go ahead and do problems 2A and 2B on your own right now using your calculator. So let's continue looking at this concept of what the definite integral of velocity means in terms of a graph. So in this example, it says the graph of the velocity measured in feet per second of a particle moving along the x-axis is pictured below. The position P of t of the particle at t equals 8 is 12. So we're saying here P of 8 equals 12. Use the graph of v of t to answer the questions that fall below. What is the position of the particle at t equals 3? Okay, so we need to remember we have no equation here, and this is the graph of velocity. So we have to think about it in terms of what we know. Well, we know that the definite integral of velocity, okay, of the upper with an upper and lower limit is equal to the difference in the change of position. Okay? So here we're going to use our unknown and our known. Now, luckily for us, we know P of 3, okay? We know P of 8. It equals 12. It was given to us, and we're being asked to find P of 3. But now we have to find the value of this definite integral. And because we're given the graph, we know it's the area. So it's the area from 3 to 8. Okay, it's the area from 3 to 8. So we're going to have to break up this area on top as a rectangle and a triangle. So the rectangle area is going to be 1 times 5. The triangle area on top is going to be 1/2 times 2 times 5. And then we're going to have to subtract, all right, the area on the bottom. All right, we're going to have to subtract the area on the bottom, which would be minus 1/2 times 2 times 2. And that will equal 12 minus P of 3. Now, when we get that, all right, we would end up getting 5 plus 5 minus 2 equals 12 minus p of 3. All right, so we get 8 is equal to 12 minus p of 3. Therefore, p of 3 is going to equal 4 feet. Now, I broke up this shape on top into a rectangle and a triangle. You could have treated that as a trapezoid. All right, you could have treated that as a trapezoid if you wanted to. All right, so you may have used a different formula to find that area. Now, let's look at B. What is the acceleration when t equals 5? Well, we're looking for acceleration at t equals 5. Well, remember, that's acceleration is the derivative of velocity. All right, it is the derivative of velocity. All right, so how would we do this? So because we don't have an equation here, we're going to have to treat this as a rock. So the acceleration of 5 is going to be due to a rock, the velocity of 6 minus the velocity of 4 all over 6 minus 4. So we get 0 minus 5 over 2. So our acceleration is going to be negative 5/2 feet per second squared. All right, so for part C, what is the net distance from 0 to 10? So remember, net is just equal to the definite integral from 0 to 10 of the velocity. So we're going to break this up into two. We're going to break it up into the trapezoid, all right, and the triangle, okay? We're going to break it up into the trapezoid and the triangle. So 1/2 times 5 times 6 plus 2, that's the area of the trapezoid, plus 1/2 times 4 times negative 2. And remember, I wrote this as plus, but I introduced the negative here as the height. All right, you could have just done minus 1/2 times 4 times 2. And we get 20 minus 4. So our net distance is 16 feet. Now, the key thing here is what is our total distance for D? Well, remember, total distance is the absolute value of the integral. So essentially, it's the absolute value of 20 plus the absolute value of negative 4. So it's 24 feet. That is the total distance traveled. Remember, it's absolute value in this case. All right. So the last thing we're going to talk about today is in terms of a table. All right. In terms of a table. So the table above shows values of the velocity in meters per second of a particle moving along the x-axis. What does the value of the definite integral from 0 to 18 of v of t d of t represent? Well, what does that represent? What does this equation represent? Well, we know it's going to be, this essentially equals p of 18 minus p of 0, okay, which is the total distance the particle moves from t equals 0 to t equals 18 seconds. All right, what else can you do from a table? What else can we do from a table? Well, we can use Riemann's sum of 6 subintervals to estimate what this definite integral equals. All right, so if we think about it, let's look at what our 6 subintervals are. from 0 to 3, from 3 to 6, from 6 to 9, from 9 to 12, from 12 to 15, and from 15 to 18. And we're talking about left Riemann. All right, so remember, we're using rectangles here. All right, so to find the value of this definite integral, all right, it would be 3 times 2.3 plus 3 times 2.7 plus 3 times 2.0 plus 3 times 1.3 plus 3 times 1 plus 3 times 1.7. All right, and if you got that, it would approximate that the total distance traveled from 0 to 8 using the left Riemann sum is 33 meters. I would like you to do C on your own now using right Riemann sum. All right, now that you've found right Riemann sum to find the value of the definite integral, I want you to also find the next 3 questions. Midpoint Riemann sum of 3 subintervals, trapezoidal sum of 6 subintervals, and find the average acceleration. I have copied the table down for you here to complete the next 3 problems. Once you are done with that, you are done and ready to move on to the worksheet. Have a great day.